Hi students, our study today is about revolving about x any vertical or horizontal line. This is called disk method. The things we're going to talk about it today. First of all, contrary to the cross section, in the cross section, it will be given either the cross section is a rectangle, is a triangle, it is a square, it is a circle, it's a half a disc, whatever. Here, no, it's a circular rotation. Always you have that shape. So if you cut the cross section inside, you're going to have what? A disc. So here always you have volume is, we know that the area of a circle or a disc is pi r square from A, for example, from A till B, for example, in this example, from 0 till 4, and the area of a circle, as we said, pi r square. So our aim is to find r. So what does it mean, disk method? Disk method, it means when the rotation axis, like here, is one of the boundaries. So here, if you're going to rotate here across the x-axis, as you can see, the x-axis is a boundary of the curve. So this is called the disk method. If it is not a boundary, it will be washer method. In the second video, you will understand. So always volume equal, as we did before in the cross section, which was ax, but here the radius of a circle is pi r square. So the same at the cross section, but here always circular. So here let us take example. Suppose I want to rotate the region y equal root x from 0 till 4, revolve about the x-axis. Find the volume of the generated shape. So first of all, because I want to revolve across the x-axis, and x-axis is the boundary of y equal root x. As you can see, it's a boundary. So I want to revolve this. So it's a disk method. So the volume from 0 till 4, it's pi r square. Need to find r. So if you pick any point x, it will touch the curve, which is root x. So the radius here is nothing else than root x. So the volume will be pi from 0 till 4 of r square root x square, and you get this answer. However, in the problem after, I want same. This is y equal. This is the x-axis. Here, don't forget that this is the x-axis. This is y equal root x. I want to revolve it from 0 till 4, and the boundary is from root x, y equal root x, till y equal -1. So this is the boundary from 0 till 4. So as you can see here, I want to revolve this shape, that here the red one, across. So you're going to get this shape down, and here this is the axis of rotation. First of all, I need to find the radius. So certainly the radius can't be star. It's a disk method because the axis of rotation is a boundary. So the volume is the same from 0 to 4 pi r square, but I need to find the radius. You know that from here till here, this is what? Root x, because this is the graph root x from the x-axis. And from here till here, this is what here you have 1. So what will be the radius, this whole radius here? It will be root x plus 1. So here in that case, the radius will be root x plus 1 all square. Above it was, because I'm rotating across the x-axis, so the radius directly was the elevation to the curve, which is root x. But since I'm going to rotate it here from a line, a horizontal line below, so it will be root x from the x-axis up, and you add to it 1. If you have, for example, -2, you add to it 2. So it will be pi. This is the radius. You square it, you expand. This is an ordinary calculation for integral. More example. Suppose the same example, y equal root x. I want the boundary from till x equal to 4. It is between y equal root x and y equal to 1. So I have two curves, y equal to 1, y equal root x. I find first of all the intersection. It is 1, 1. So I want from 1, 1, because I want the area enclosed between these two till 4, and the rotation axis is 1. So here I want to rotate of that form, like you can see here. So it will be that shape. So you want to rotate like this. So here the radius. To find the radius, and I know from here till here is root x. This whole thing is root x. And I know from here till here it is 1. So what will be this radius here, that you can see it here very clear? It will be root x minus this distance, which is 1. So the radius here will be root x minus 1. And it will be from 1 till 4, because the area enclosed is from 1 till 4. Pi r square, you do this square, the radius, you can expand and you can find the volume. More examples. Suppose here I want, you have y equal x square. This is y equal to x square. The area enclosed between y equal x square, x equal to 2, this is the line x equal to 2. The y-axis, okay, sorry, not the y-axis, yes, the y-axis here, this is the y-axis, and y equal minus 2. So here you have the region between y equal to minus 2, the y-axis, x equal to 4, and y equal x squared. So this region, I want to revolve it across y equal minus 2. So my aim is to find the radius, because first of all, this is a disk method. Why disk method? Because this the rotation axis is a boundary. This is all the area I want, and the rotation axis is a boundary of the area. So I want to find the radius from here till here. So I know from here till here it's x squared. From the x-axis to the curve, this is x squared. And I know down it is 2 here. So what will be the radius? It will be x squared here. Then this function is x squared plus 2. And you have from 0 till 2, and you square the radius. You can solve and you get the answer. Now I want to go to vertical rotation. Like we did in the area, vertical rotation, I don't have x, I have dy. The same story here, but I take vertical. Let us take the example. Find the volume of the solid generated by revolving the region between the y-axis, this is the y-axis, and the curve x equal 2 over y, between 1 and 4. The 1 and 4, the y is between 1 and 4. So here y from 1 till 4. You want to revolve it. If you revolve it, you're going to get like this. And you're going to get here just opposite symmetric with respect to that one. So first of all, I want to find the radius. First of all, it's disk method. Why? Because this, as you can see, this area, the rotation axis is a boundary. So I need to find this radius. So the radius is nothing else than x equal 2 over y. Okay, because from here till here, if this is y, this is its x. So it will be the x here, if you project it, it will be 2 over y. This is 2 over y, this is y, and I want the radius, so this is 2 over y. I want it from 1 till 4. I take now on the y-axis, not on the x-axis, so I don't take into consideration 0, 2. So from 1 till 4, pi r square, where the radius is 2 over y. You can check the answer. More example to understand. Suppose you have the same picture that I had. This is the y-axis. I want to revolve from y from 1 till 4, as you can see. About x equal minus 2, and the region is between x equal minus 2 and x equal 2 over y, between that curve and this axis, which is at the same time axis of rotation, and between 1 and 4. Y is between 1 and 4. Since this is the area I want to revolve it, since the axis of rotation is a boundary, so it's a disk method, so it's the form, the volume is pi from 1 till 4, pi r squared. I need to find the radius. You all know this is the y-axis, so from here till here now, because it's vertical, this is 2 over y, because this is the function 2 over y. And from here till here you have 2. So what will be the radius? It will be this 2 here, the distance from here till here, because here we have x equal minus 2, we add to it 2 over y. Okay, so the radius will be 2 over y plus 2. If you square it, you solve it, you solve an ordinary integral, you can get the volume. And the last example here, I want to rotate the solid between x equal to 2, x equal to 2, this is the y-axis, first of all, this is the x, this is x equal to 2, between x equal to 2, the curve x equal 2 over y. So I have this region here. Let me tell you which region. So I have this region between the 2 and 1, y between 1 and 4. Now my aim, because it's vertical, so it's dy, not dx. So it's a vertical rotation. Before in the first part, it was horizontal rotation like this. It will be dx. So I need to find the radius. From here till here, you all know this is 2 over y. And from here till here, it's 2. This is my radius. From here till here, this is the radius. This is a radius. This is a radius. So what will be this measure? It will be the 2 minus 2 over y. This is because 2 until that point here, 2 over y. So the radius will be 2 minus 2 over y. And the volume will be pi from 1 till 4, 2 minus the radius square. You can calculate, do the expand here and do an ordinary calculation of integral. So in this video, we learned the disk method. Remains to finish from area and volume. As the last video you're going to watch is about washer method, where washer method, the axis of rotation is not a boundary. Here you can see always the axis of rotation here is a boundary.